Hello everyone, I'm Sebastian Y, and this is Managerial Economics. In this video, we're going to put supply and demand together to solve for equilibrium. Let's start out with a quick sketch of a market. Quantity, price, demand, and supply. The market equilibrium occurs at the price at which the quantity supplied and quantity demanded are equal. I will denote these as PE and QE. If the price is above the equilibrium price, then we get quantity supplied greater than quantity demanded, which we call a surplus, not to be confused with consumer and producer surplus. If the price is below the equilibrium price, then what we get is quantity demanded bigger than quantity supplied, which is a shortage. A market experiencing a surplus or shortage will naturally adjust into equilibrium. At the equilibrium price, we sometimes say that the market clears. That is, there's no excess demand, no excess supply. We will use our example beer supply and demand functions from the previous two videos to find the equilibrium of our beer market. The way that we're going to go about this is to solve them together as a system of equations. We know we need to find the price that makes the two quantities the same. So all we're going to do is set these two things equal to each other. So what we'll get is negative 600 plus 20 PB equals 900 minus 10 PB. Now we need to just do a little bit of algebra to solve for this. I'm going to add 600 to both sides. So on the right-hand side, we're going to get 1500. And then I'm also going to add 10 PB to both sides. And that's going to give me 30 PB. All that's left is to divide both sides by 30, which is going to give me PB equals 50. I'll throw an E on that to denote that that's our equilibrium. For the equilibrium quantity, I'm now going to plug the 50 we just got into either of these equations. Since they're set equal to each other, it does not matter which one I use. Let's use our supply function. We get minus 600 plus 20 times 50. 20 times 50 is 1,000, so that leaves us with 400. Had I used the demand function, I would get the same thing. 900 minus 10 times 50. 10 times 50 is 500, so that's going to leave me with 400 as well. Let's go ahead and graph our market. I won't go through this in as much detail as before, since we already showed how to graph these individually in the last two videos. For the demand function, we use our intercepts of 900 on the quantity side and 90 on the price side. Draw a straight line between them. Our supply function has an intercept of 30. We also want to mark out our equilibrium, which is at 50, and a quantity of 400. And so we know our supply function is going to look something like this. Mark those out with supply and demand, S and D, and that's our graph. To calculate the consumer surplus, that's going to be this triangle right here. And our producer surplus is going to be this triangle down here. Consumer surplus is a triangle with a base of 400, height of 90 minus 50, that's 40, divided by 2, which is 8,000. Our producer surplus also has a base of 400, but a height of 50 minus 30, that's 20. Divide by 2, we get 4,000. Putting this all together, the total economic welfare in the market is measured by the total surplus, which is the sum of those two. So that's going to come out to 8,000 plus 4,000, which is 12,000. Another way we can approach our supply and demand is with the inverse functions. That is the inverse demand function and the inverse supply function. This just means that we take our regular demand and supply functions and we solve them for price instead of quantity. Let me show you an example for our demand function. Our demand function is QBD equals 900 minus 10 PB. This is our demand function. To get the inverse demand, all we need to do is solve this thing for PB. So I'm going to add 10 PB to both sides. That's going to give me 10 PB plus QBD equals 900. Now I'm going to subtract QBD from both sides. It's going to give me 10 PB equals 900 minus QBD. And now divide both sides by 10. This is going to be our inverse demand function. Now this is a very common mistake, so be careful here when we're dividing both sides by 10. We need to divide every single term by 10. So 900 divided by 10, 90. QB divided by 10 as well. To do this with our supply function is QBS equals negative 600 plus 20 PB. To get the inverse supply, I will add 600 to both sides, so we get QBS plus 600 equals 20 PB. Divide both sides by 20. Again, make sure to be careful about this. We get QBS over 20 plus 600 divided by 20, which is 30. And that is our inverse supply. Just for consistency, I'm going to flip this thing around and write PB equals QBS over 20 plus 30. I want to point out here that on the graph, these are the exact same equations as before. We've just rearranged them. The reason for doing this is that sometimes it's more convenient to have things solved for quantity instead of price, and several weeks from now we will start to see some examples as to where we might use these. We can also use the inverse functions to solve for the equilibrium. Since both of these are equal to PB, we can set them equal to each other, so we can have 90 minus QBD over 10 equal QBS over 20 plus 30, and then solve for QB. Now to do this, we're going to have to add some fractions. So for a quick review, we can only add fractions when the denominators are the same. So I'm going to take my QBD over 10 and multiply both the top and the bottom by 2. So I'm going to get minus 2 QBD over 20 equals QBS over 20 plus 30. Since we're finding the equilibrium, we know these two quantities are going to be the same. So I'm just going to replace the D and S with E for equilibrium. And now we are going to add the 2 QB over 20 over to both sides. 90 equals 3 QBE over 20 plus 30. Subtract 30 from both sides, we get 60 over there. Now multiply both sides by 20 over 3. So QBE will be 60 times 20 over 3, which is 400, just like we got before. We can then plug that 400 into either the inverse supply or demand function to get the equilibrium price. I'll plug it into the inverse demand function. So we get 90 minus 400 over 10. 400 over 10 is 40, so we get 90 minus 40 equals 50, which is exactly what we got before. If you want to do it this way, do it this way. Solve for the inverse demands. You get the exact same answer if we solve the system of equations, because at the end of the day, they are the same equations, just rearranged. Our next topic is comparative statics. Comparative statics is the study of what happens to the equilibrium when some market conditions change that ultimately shifts one of the curves. So for example, we might think about what would happen to the equilibrium if the price of some inputs increased, or the price of a substitute decreased, or consumer income increased, something like that. Let's take our example supply and demand functions that we've been using and do a little bit of comparative statics here. Suppose that the price of inputs decreased, which shifts the supply curve 600 units to the right. So that's going to add 600 to our supply function. The negative 600 and positive 600 are going to cancel out, and we're just going to have 20 PB. To figure out the new equilibrium, we'll set all these equal to each other. 20 PB is now equal to 900 minus 10 PB. Add 10 PB to both sides. Divide both sides by 30. 900 divided by 30 is 30. I'll put an E on that for equilibrium. To figure out our equilibrium quantity, we plug the 30 back into either one of these. In this case, the supply function's easier, so I'll do that. 20 times 30 is 600. I'm going to draw a graph of this. I'll draw in our original functions that looked something like this. When we draw graphs in this class, it doesn't have to be exact, but you want to get it looking more or less right and get the intercepts right. So let me mark the intercepts. We're 990 and 30. Our old equilibrium was 50 and 400. Our new equilibrium is at 30 and 600. It was the supply curve that shifted, so let's draw that in. Our new supply function is QBS equals 20 PB. Since there's no constant term here, that means that our new supply curve comes out of the origin. And we know that it's going to go through our new equilibrium point, so our new supply is going to look something like this, shifted to the right. We can see from this example that when the supply curve shifts to the right, equilibrium price comes down and quantity goes up. Had the supply shifted to the left, we would have had the opposite result. The price goes up, quantity goes down. Let's look at one more example, this time with our demand curve shifting. Suppose that the price of a substitute, such as wine, increases so that the quantity supplied is 300 higher at every price. So we're going to add 300 on right here, and what we get is 1200 minus 10 PB. As usual, we'll do the algebra to figure out our new equilibrium. We're pretty used to doing this, so I'll move pretty quickly. Add 10 PB to both sides, add 600 to both sides, divide both sides by 30. Our equilibrium is going to be 60. Plug that into either one of these to get our equilibrium quantity. I will use the demand function this time. So plug in the 60 right there. 10 times 60 is 600. That's going to leave us with quantity of 600. I've gone ahead and redrawn our original supply and demand curves. We'll mark out the old equilibrium again, which was 50 and 400. Our new demand curve is 1200 minus 10 PB, meaning that our quantity intercept is now 1200, somewhere about here, and our new price intercept is going to be 120, 1200 divided by 10. That's going to be somewhere over here. It's going to be a parallel shift to the right of our demand curve. It's going to look something like this. Let's mark out our new equilibrium, which, as we know, is price of 60 and a quantity of 600. What's happened here is that a shift to the right of the demand curve moves us along the supply curve up and to the right, so our equilibrium price and quantity both increase. Had the opposite happened and the demand curve shifted to the left, then they both would have decreased. And that is it for equilibrium and comparative statics. In the next video, we're going to talk about elasticity.